Hello students, this is the next video of chapter electrochemistry. The topic is electrolysis of molten NaCl. Here is the diagram of electrolysis of fused NaCl. First one is the construction of electrolytic cell. This cell consists of a container that contains fused NaCl. This cell consists of a container that contains a fused NaCl solution. Two graphite or carbon electrodes are immersed in it. This is two carbon electrodes are immersed in the fused NaCl. They are connected by metallic wire to a source of current battery. Means these two electrodes are connected to a battery for the direct source of current. The electrode connected to negative electrode of battery is cathode. The electrode which is connected to negative electrode of battery, this is the cathode, and the electrode which is connected to positive electrode of battery, that is the anode. This is the construction of electrolytic cell. Next one is the working of cell. In electrolysis of molten NaCl, the fused NaCl contain Na positive and Cl negative ion which are free to mobile. Here this is the solution of fused NaCl, and in this NaCl, Na positive ion and Cl negative ion that are free to mobile. When current is flowing, cathode attracts Na positive ion. Here cathode is negative and that negative is attract the positive, means that cathode attract the Na positive ions, and anode is positive and that anode attract the Cl negative ion. As these particles are charged, their motion constitute an electric current. When these ions reach the respective electrode, the discharge according to following reaction. When these two ions are reached to respective electrodes, the reactions are carried out. First one is the, here this is the two electrodes are present, means at one electrode this is the reduction half reaction takes place, and at another electrode that is the oxidation half reaction takes place. Here reduction half reaction at cathode, means at that electrode reduction half reaction takes place. Each Na positive ion reaching the cathode accept electron from cathode and reduce to metallic sodium. Here this Na positive ion reaching to cathode and accept electron from that cathode, and these Na positive ions are converted into metallic sodium or Na solid. Here Na positive plus electron, it gives Na solid, means metallic sodium. Next one is the oxidation half reaction at anode. Next one is the oxidation half reaction at anode. At anode, each Cl ion that reach the anode give one electron to anode and oxidize to neutral Cl in primary process. Here at anode, that anode attracts the Cl negative ion, and that Cl negative ion give electron to anode, and that Cl negative is converted into Cl neutral. Here twice Cl negative, it gives Cl atom plus Cl atom plus 2 electron. In the next process or in the second process, this is the primary process at oxidation half reaction at anode. In the second process, the two Cl atoms, this one and this one, combine to form Cl2 gas in secondary process. So the secondary process reaction is Cl gas plus Cl gas, it gives Cl2 gas. The overall oxidation at anode. Here at anode, this is the two process, primary process and secondary process, and oxidation overall reaction is the combination of primary process and secondary process. Twice Cl negative, it gives Cl plus 2 negative. This is the primary process. and Cl plus Cl, it gives twice Cl gaseous state. This is the secondary process. The overall oxidation at anode, this is the combination of these two, twice Cl negative. Here this Cl cancel, this Cl cancel. The overall reaction is twice Cl negative. It gives Cl2 gas plus 2 electron. This is the overall oxidation at anode. Next is the net cell reaction, means the overall cell reaction, means here this is the reduction half reaction at cathode and oxidation half reaction at anode, and the overall cell reaction is the combination of or sum of these two reactions, these two half reactions, that is the net cell reaction. Here twice Na positive plus twice electron, it gives twice Na solid. This is the reduction half reaction. And twice Cl negative, it gives Cl2 gas plus 2 electron. This is the oxidation half reaction. Here this is the twice Na positive, twice electron and twice Na. But here this is the Na positive, 1 electron, it gives 1 Na solid. Why we multiply this reduction half reaction by 2? Because in overall reaction the electron becomes cancelled, and so in oxidation half reaction there are 2 electrons. For cancelling these 2 electrons, we multiply this reaction by 2. So here 2 electron cancel, and the overall cell reaction is twice Na positive plus twice Cl negative, it gives twice Na solid plus Cl2 gas. This is the overall cell reaction in electrolysis of molten NaCl. Then result of electrolysis. Here a pale green Cl2 gas is released at anode. Here a pale green color Cl2 gas is released at anode. Here anode attracts Cl negative, and here this is the bubbling of Cl2 takes place. This is the pale green color Cl2 gas is released at anode. Next is the molten silvery white sodium form at cathode and float on the top of molten NaCl. Here at cathode, this is the whitish particle seen, and this is the deposition of solid sodium at cathode electrode, and also that solid sodium is floated on the surface of or top of the fused NaCl solution. This is the electrolysis of molten NaCl.